The last topic I want to talk about here in chapter 14 is the idea that we're going to pursue a lot further in chapter 15 of how we can use galvanic cells to find concentrations. So let's consider the galvanic cell that's here. This is from your textbook. It's figure 14-10 if you want to check it out. And the idea here is that we have set up a galvanic cell where we know everything except for one concentration. And using the Nernst equation, we can find that concentration. In particular, the concentration we're interested in is what's the concentration of H plus on this left-hand side. So what's going on here in terms of the electrochemistry? Well, on the right-hand side, we have this silver chloride electrode. And this is something where we can look up the standard reduction potential, and we'll see this quite a bit for the next chapter when we're talking about potentiometry. So the silver chloride electrode is a very commonly used electrode. But we have this reaction between silver chloride and silver, and this has a known standard potential. So we can look this up. E naught plus is 0.222 volts. Okay, and on the left-hand side, so on our negative electrode, we have the standard potential would be this would be the standard hydrogen electrode. So E naught for our negative side is 0 volts by definition, because this is under standard conditions. This is the hydrogen electrode. Now, neither of these are under standard conditions. For our silver chloride electrode, our concentration of chloride is 0.1 molar, so it's not activity of 1. And here, our concentration of H plus is something that's not 1 molar, right? But that's our unknown. And so the whole goal of this electrode, just to make it clear, is we have here a mixture of sodium acetate and acetic acid. And if we can find the concentration of H plus, those are all things that go into finding Ka. So, while overall the cell is not at equilibrium, we can look up here and it has a voltage of positive 0.503 volts. That means that the cell is not at equilibrium. It would only be at equilibrium if it was at 0 volts. We can consider each side of the cell is at equilibrium. So we've established an equilibrium in this mixture here and an equilibrium in this mixture here. The two cells are not balanced relative to each other, but within each one, they've reached equilibrium. And so if we can find the concentration of H plus and we know the concentrations of acetate and acetic acid, that actually gives us a way to find Ka. So this is a buffer that we've created on the left-hand side, and we want to find Ka by calculating H plus. That's our one unknown in this. So if we go ahead and write out the Nernst equation for this total cell, we'll see that there's only one thing in here that we don't know. So we can write out that E total is equal to E naught total. So we know the standard potentials. All right, so this will be 0.222. All right, that's known. Minus 0.05916 volts divided by 1. All right, so this is times the log of chloride. So this is for the silver chloride electrode. And we'll subtract our negative electrode, which means we'll add 0.05916 volts divided by 2 times the log of the pressure in bar, so 1 bar, divided by a concentration of H plus squared. Now, I'm just going to erase this here. We know what the concentration of chloride is, so I'm just going to plug this in directly. This is equal to 0.1 molar. And so this value, E naught total, we know this is 0.222 volts minus 0 volts, or in other words, 0.222. And the value of E total is measured on the potentiometer as positive 0.503 volts. That leaves just one thing we don't know. The only thing we don't know in this equation is the concentration of H plus. Now you may be wondering why I have 2's here. I'm writing this equation on the left-hand side as 2H plus 2 electrons going to H2 gas. Just a reminder that this is at 1 bar. we could write this with only a single electron. Then we would need to remember the 1/2 that would go on the H2. So one way or the other, it works either way. Okay, so if we then plug in all the values here, we can solve this, right? And so if we solve this, I won't go through all the algebra, but we get concentration of H plus equals 1.8 times 10 to the minus 4 molar. So this allows us to determine Ka, because we can say Ka is equal to the concentration of acetate times the concentration of H plus divided by the concentration of acetic acid, and plugging in all the values that we have. So these concentrations here, you probably can't see that very well, these concentrations here, as well as this concentration, again skipping some steps, but we get that this is 1.8 times 10 to the minus 5. So this is an example of how we can get a relationship between a concentration for something that we have in our system, when we can measure the total potential and fix everything else, we can find concentrations. And so this is really the whole point of ion selective electrodes that we're going to look at in the next chapter. So that's it for chapter 14.